Cottage cheese pizza, cottage cheese pizza. Okay, so today what we're going to look at is some inverse trigonometric functions, or inverse SOHCAHTOA. When we're doing this, what we need to start thinking about is the idea of the fact that sine, cosine, and tangent are functions. We might recall for a function like f of x, this could have some value. Let's say it's, I don't know, 7. Okay? This in our math classes also kind of gives us the idea that y equals 7 here. Or let's make it in this case 7x, because this is a function of x, right? So if I was given a value for x, like f of 2, this would be like 7 multiplied by 2, because I input that value of 2 in for x. So a 2 showed up where the x is, and that's because we put a 2 for x. Okay? This would say, in this case, y equals 14. So if x equals 2, y equals 14, that'd be a classic orders pair like 2, 14, x, y. Now, we could flip this. We could say, hey, if y equals 21, what does x equal then? Well, you know, algebraically, we could easily do that. We could plug in 21 for y and then divide by 7. We'd find that x equals 3. But what we're actually doing here is we're setting up an inverse function. What we're saying here is on a function of y, we're going to get x. Or another way of writing this is the inverse function, or f to the negative 1. Now, that's not a power. That's saying inverse of x. And this would equal y over 7. So this is our inverse function here. It's essentially saying, look, this time instead of having x and solving y, I'm going to have y and solve for x. And that's what we're going to do in this case here with these inverse trigonometric functions. As we see, we can use this to actually solve for the angles. So far with SOHCAHTOA, we've always had one of the sides, an adjacent, an opposite, or a hypotenuse, and then we've solved for another side because we have an angle somewhere. But if we don't have an angle, then we could solve for it if we needed to, if we had two other sides. So the way we're actually going to do this, we're going to need our calculator for this. None of these numbers are very intuitive unless you were thinking about this for a while. So I'm going to pull out a calculator here. This is our fake TI-84 that we've got. And if we look at our first example here, sine of A equals 0.4226. If I want to solve for A, what I'm going to do is I'm going to take the inverse sine. Sometimes it's also called the arc sine by your math professors. Sometimes teachers will write it like this, sine to the negative first, or they'll write it as arc sine, and they'll do this for cosine and tangent as well. But if we say take the arc sine or the inverse sine of this number, we're going to get back the angle. So we'll take the inverse sine of 0.4226 and see what we get here. It's important for us in a physics class. We like to use radians. You don't have to use we like to use degrees. Excuse me. We like to use degrees in this class. You don't have to use degrees. You could use radians if you want. Nothing wrong with it. But traditionally in this class we're going to use degrees. So we're going to take the inverse sine. So there's inverse sine, sine to the negative first power of 0.4226. Close that parenthesis because I'm paranoid. And I hit enter, and I get just about 25 degrees here, okay? So I get just about 25 degrees here, 24.99, whatever. That's 25 in my opinion, okay? So take a second, pause this video, see if you can find the angle here for B, R, and Z for our next 3 examples using the inverse functions that you see. So pause it, try them out, try out these things. Why didn't you pause yet? Why didn't you pause yet? I could sing for about 15 minutes if I had to. Why didn't you pause yet? Did you pause? Did you try them? Seriously, you got to try these. Okay, so let's try this one out. Cosine of B. So that's 0.6691. So that's going to be inverse cosine. So that's second cosine. And then 0.6691. And I get a value of 48. So boom. Let's drop in 48 degrees. Let's do inverse tangent. So inverse tangent of 0.24, what was that number? Oh, 26, ugh. Delete, no, go back, delete. 2679, enter. It's going to be a value about 15. That's nice. These are nice values. Very kind of me. And then for z, 0.829. So inverse sine of 0.829. Hit enter. We get 55.99. So that's really 56. Close enough. So 56 degrees. Okay. Now, if you're trying this out on your phone, you might not actually see a sine, cosine, or tangent button. You might actually have to twist your phone sideways in order to open up all of the options for you to see there. And just like before, if you're using your phone, you might have to put in the number first, the 0.2679, the 0.4226, the 0.6691, the 0.8290, and then you might have to hit inverse sine, inverse cosine, inverse tangent. Sometimes calculators are a little weird. You have to understand your syntax and the way that you punch things in. But if you're getting wrong numbers, try a few different ways on your phone or your calculator. See if you can come up with these angles that we got here in order to figure that out. And that'll let you know like what order do you have to type things into to make sure things work out. Okay. Now it's important for us to recognize that these numbers here, the 0.4226, the 0.2679, 0.6691, 0.8290, these are actually adjacent over hypotenuse, opposite over adjacent, and opposite over hypotenuse. Like, these are actual values we could get off of a triangle. So if we come down here and we take a look at this example, we could actually find this angle x because we have two sides of a right triangle, and all the triangles we're dealing with are right. They must be right. So what we can do here is let's just label our triangle. We know this is our angle, so going across from it, this is our opposite. This long side here across from the 90 degrees, the hypotenuse, and that makes this the adjacent. Well, if I write out SOHCAHTOA, in all of its glory, SOHCAHTOA, SOHCAHTOA. Well, what do I have? I have an opposite, so sine and tangent, that means cosine's out of here. Get out of here. And I have hypotenuse, which is leaving me only with sine. So what I can say is that the sine of the angle equals the opposite over hypotenuse, 5 over 14. And that means if I want to actually find what the angle is, I'll take the inverse sine or the arc sine of the number. So this is inverse sine of 5 over 14, whatever that is, and that's going to equal my angle x. I'm undoing what we've done previously, okay? And if we rush this through a calculator real quick, we'll do inverse sine, and you can actually, because these are in parentheses, you can do division within here. So 5 divided by 14 will happen first, and then the inverse sine will be taken, and we get 20.92 degrees. Where'd that all go? Did that just all go away? What happened? Undo. Ha! There we go. I don't know what happened there. So that x here is going to be 20.92 degrees. Okay, so we set up the sine, cosine, tangent, whatever we had like before, but now we're taking the inverse of that of the number. So for our second example here, try this out. Find this missing angle x, mark the angle, label your sides, and then see what you're given here. Pick a sine, cosine, or tangent, and try to figure out what that value of x is, okay? So once again, you've got to pause the video. Why aren't you pausing yet? Seriously, try this out. Okay. Marked. Cutting through the angle to get to the opposite side. Across from the 90 degrees is my hypotenuse, and that makes this the adjacent. I always write his name because it's the greatest in the world. Chief SOHCAHTOA. Okay, and what do I have? I have an opposite and an adjacent. So I've got an opposite, and an adjacent. Oh, I've just highlighted tangent, so it looks like I'm going to use a tangent function here to describe this. So the tangent of my angle, x, is equal to the opposite, 5, over the adjacent, 14. And now I actually want to solve for x, so I will take the inverse tangent of 5 over 14. A little mathematical fact, if you take what we're actually doing here is we are actually taking the inverse tangent of tangent of x. But what happens here is when you take the inverse function of a function, the functions work each other out, and you actually just get the variable that's left. So this will just equal x. And since I took the inverse function on the left, I have to do it on the right. So there's your inverse tangent over there, 5 over 14. And this is just up for a calculator to solve at this point. So let's try that out. So inverse tangent of 5 over 14 equals 19.625. Cool. We'll just call this 19.6 degrees. Okay? And that's a fairly straightforward thing there in order to solve that. So not too bad for the inverse functions. Now, this is a little bit extra, in case you want to see this in the future. But what you'll actually find is that tangent of theta, some angle, is actually pretty close to the sine of theta whenever you're around 15 degrees. Okay, so whenever theta is kind of like about less than 15 degrees, that'll be true. This is what's known as a small angle approximation. We use it in some more complicated physics moves, in AP Physics 2 and then beyond, whenever you're trying to make things look a little bit easier. Furthermore, if your angle is in radians, what you can actually say, if you're in rads, what you can actually say is tangent of theta is about equal to the sine of theta, which is about equal to just theta, which is kind of a neat thing. And we can actually prove this real quick. Just check this out. I'm going to set this mode back into radians. So I'm back into radians now. Oops. Now I'm back into radians. And watch this. I'm going to take the sine of something very small. So the sine of like, let's do 0.2. If I hit enter on that, I get 0.198, which, yeah, 0.198 is pretty much 0.2. And if I take the tangent of 0.2, I get 0.2027. So those are like really, really close to one another. So if you're within about like 15 degrees or whatever that equates to in radian measure, sine and tangent are pretty much the same, and they are very much identical to theta for that. So that's called the small angle theorem. You won't really need that this year, but if you're curious about it, it's kind of a cool thing. So there's your small angle theorem. That's how you spell theorem, okay? But with that, this is finished. You've learned inverse sine, inverse cosine, inverse tangent. We can use that in all of our stuff, and we'll be using this throughout the vector unit and then beyond whenever we do some more complicated physics this year. But for now, adios and take it easy.